So this is our part 2 on inferential stats. What I'd like you to do is take a reread of page 60 to 61, especially that little section on when is it observed difference reliable and when is difference significant. And then pause me and come back. Okay, so I showed you this slide in class. Whenever we're doing an experiment, at the end of the experiment, we're going to have results from our control group who were not exposed to the independent variable, and our experimental group, they were exposed to the independent variable. In this one, we're talking about a test of memory. So let's just say our independent variable was a new study aid or study process. We're going to perform descriptive stats, and we're going to get this measure of central tendency and this measure of variation. This is a purposely very small group. This would not be helpful. Actually, this is only helpful for an example. We would want many, many more data points than this. Okay, so what was Myers trying to say about reliability and generalization and kind of this checklist almost for statistical significance that he put forth? I'm going to kind of conflate those two sections kind of into one. I want you to think of it as a checklist for statistical significance. So stay with me on this side of the screen, okay? Now, you still need to perform the t-test, the chi-square. We don't need to perform it, but one would still need to perform it to confirm statistical significance. But if you meet these criteria, if you can put these little check marks next to your data after you've done your statistical analysis of it, you are more likely, mark my words, you are more likely to have statistically significant data. So the first thing is actually just makes sense. If you just, if you're anxious about this section, just allow yourself to breathe and just think about this. If you have an experimental group and a control group, the thing you're going to compare is, in this one, how many words did they get right on average? And you're going to want to see a difference, aren't you? In this example, you're going to want to see a higher mean. People got more words right because of my new study aid, right? As opposed to the people who were exposed to nothing, right? To no type of intervention. We're going to want to see, right? If we want our independent variable to make a difference in the dependent variable, we're going to want to see a difference between the means. So the first thing is compare the means between the two groups. Okay. The second one is larger representative samples. You want a larger size, the more reliable. So basically, the more data points we have, the more that produces reliable data than smaller data points. That's kind of common sense, right? Easier to generalize when you have 100,000 data points as opposed to 2, right? So the more data is usually better in terms of being able to generalize and give us reliability, okay? Now, the third one is more connected to the first, this one in blue. We have to look at the standard deviation within the two groups. And what we want is a smaller standard deviation within the two groups. If we meet these three criteria, the more likely we are to be on the road to statistically significant data. So the standard deviation within the groups. Remember that this tells me how much our scores vary from our mean. I'm circling our mean in the distribution tables, right? How much these scores circulate. I want you to just listen to this sentence. This kind of helped me understand this concept a little bit. So see if it helped you. If the scores of both groups are mostly packed close to the means don't need to be separated by as much to produce a statistically significant result. However, if the scores are widely spread out, that means a high standard deviation. So again, if the scores are widely spread out, the two groups are likely to overlap quite a bit. Many participants will score in the same overlap range, no matter which group they are assigned to. We don't want to see a lot of overlap. We want to see minimal overlap, right? So we want the standard deviation between the two groups. The standard deviation, the lower the better, because that means most of the scores in our control group are clustered around 9. That means most of our our experimental group, the scores are clustered around 12. We want to see the less overlap in scores between the two, the more likely we're on the road to statistically significant data. Now, I want to introduce you to one more concept, because even if we have statistically significant data, all that tells me is that the independent variable was responsible for the changes we observed in the dependent variable. Here it would mean number of words. It just means this impacted recall. But you might want to know, well, to what effect? How strongly? Statistical significance cannot tell you that. Instead, we use something called effect size. You just need to know it exists. Effect size tells me the strength of the relationship. Okay? So it tells me more about the quality. So it's something that researchers use in addition to statistical significance. How strongly did our independent variable impact the dependent variable? All right, that's our take on inferential statistics.